Hello everyone! Today, we're diving into one of the most fundamental data types in Python, strings. By the end of this tutorial, you'll have a solid grasp on how to manipulate and work with strings in Python. So what's a string? In Python, a string is a sequence of characters. It can be defined using single quotes, double quotes, or even triple quotes. In our code, string 1 and string 2 demonstrate that strings can be defined using either single or double quotes. String 3 uses triple quotes, which allow the string to span multiple lines. This type of string is often used for documentation strings in Python functions, classes, and modules. Another thing you need to keep in mind is that strings are like an immutable list representing Unicode characters. This means we can access characters using indices and even slice strings into substrings. Moreover, you can iterate over elements of a string with a for loop, as you will do with lists. Let's see some example. Strings are sequences, so we can use indices to access specific characters. String 0 fetches the first character, which is h. Negative indices count from the end. String -1 gets the last character, o. Slicing allows us to extract a portion of a string. String 1 to 4 extracts characters from index 1, inclusive, to 4, exclusive. The for loop is used to iterate over each character of a string and print it to the console. Python offers a multiple built-in methods for strings. Let's explore a few of them. Upper converts all characters in the string to uppercase. Capitalize makes the first character of the string uppercase and the rest lowercase. Replace take two arguments, old and new. It replaces all occurrences of the old substring with the new substring. Here, all L characters are replaced with Z. We can easily join strings together, or even repeat them, using simple operators. The plus operator concatenates two strings. Here, string 1 and string 2 are joined with a space in between. The asterisk operator repeats a string a specified number of times. Here, string 1 is repeated 3 times. It's essential to understand that strings in Python are immutable. This means once a string is created, its content can't be changed. However, we can create new strings based on modifications of the original. Let's see what it means. The commented outline demonstrates that directly modifying a character in a string using indexing will result in an error. To modify a string, we often create a new string based on the original, as shown with new string variable. Lastly, Python provides several ways to format strings, allowing us to embed variables and expressions within them. The first print uses an f-string, formatted string literal, to embed the variable's name and age directly into the string. The second print uses the format method. The curly brackets placeholders in the string are replaced by the arguments provided to format, in the order they appear. That's a brief overview of strings in Python. With consistent practice, you'll find strings to be a powerful tool in your Python arsenal. Let's illustrate what we learned in this tutorial with a playful project that showcases the versatility of strings in Python. We will build our very own palindrome party app. A palindrome, if you're unfamiliar, is a word, phrase, number, or other sequences of characters that reads the same forward and backward, ignoring spaces, punctuation, and capitalization. Examples include radar, level, and the phrase, a man, a plan, a canal, Panama. Our project will take a user's input, process it, and determine if it's a palindrome. Ready? Let's jump in. Starting off, we prompt the user to input a phrase. This will be the string we check for palindrome properties. The input function displays our message and waits for the user's response, which we store in the user input variable. Here's where things get interesting. We want our palindrome checker to be flexible and ignore spaces, punctuation, and case differences. This line of code does exactly that. We're iterating over each character in the input with for e in user input. The e.isolim function checks if a character is alphanumeric, filtering out punctuation and spaces. We then join these characters together into a clean string using the join method. Finally, the lower method ensures our string is in lowercase, making our check case insensitive. Then we move to checking for a palindrome. We're comparing our processed string to its reverse, which we obtain with processed_input -1. If they match, it means our input is a palindrome. Otherwise, it's not. Based on this comparison, we print out the appropriate message. And that wraps up our code walkthrough. As you can see, with just a few lines of Python, we've crafted a robust palindrome checker. This project showcases how string manipulations, combined with Python's built-in functions, can lead to powerful results. Always remember, understanding the basics well can empower you to create amazing things. Keep experimenting, keep learning, and most importantly, keep coding.